All right, back to the nervous system now. We're gonna do another analogy. So here are two women, a mother and daughter, if you will. One of their favorite ways of staying connected is to have this tea time once a week. So they get together, they grab their favorite teacups, and they brew some tea. Now, the women like to grow their own herbs to brew for tea. Their favorite is basil tea from a flourishing basil plant they have next to their table. If you look at the plant, there is a whole gang of sprouts in that plant. Now, the best part of the afternoon to them is sitting down, carefully bringing that hot teacup up of basil tea up to their mouths and taking that first soothing sip. Now, this analogy is to remember the basal ganglia. It's another subcortical structure depicted here in blue, and there are actually two of them, one on each side. And they kind of, according to your book, cup around the thalamus, so like teacup. And you can see the thalamus here in purple again, and the blue basal ganglia cup around the thalamus. Now, the basal ganglia controls voluntary movement, like carefully picking that hot cup of liquid to your mouth, or like making intentional karate kicks. Now, you may have heard of Parkinson's disease, or maybe you know someone who has it, where these individuals have difficulty coordinating their movements. So they may have hand tremors and accidentally shake tea out of their cup when they're trying to take a sip. Now, Parkinson's disease involves a degeneration of this structure right here, the basal ganglia. All right, here's another one. So imagine you're walking through Ohio State's campus, post-pandemic, of course. There you are, you're minding your own business, when all of a sudden a giant hippo crosses your path. You keep walking, you're actively thinking to yourself, okay, I just saw a hippo. There was definitely a hippo in the quad. And then you get to a coffee shop a short while later to meet a friend, and they're like, hey, how are you? And you're like, I just saw a hippo. And then you drive home the following weekend to visit your parents after a decent amount of time has passed. And they're like, anything interesting happen at school recently? And you're like, yeah, 2 weeks ago, I saw a hippo walking through campus. Now, this is helping you remember the hippocampus, pretty straightforward. Now, hippocampus is Latin for seahorse. So it's this seahorse-shaped structure that you see here in magenta that kind of wraps around behind the temporal lobe. The hippocampus has a pretty straightforward, simple function, and that is basically all things memory. So it forms memories, like when you see that elephant on campus. It maintains that event in memory, such as when your friend asks you about it a short while later at the coffee shop. And then it finally consolidates into long-term memory. So when your parents ask you about it a couple weeks later, you can recall the event. Now, if you've seen the movie Inside Out, the hippocampus is the brain structure that kind of makes these long-term memory orbs, like playing hockey or spending time with your family or playing on a playground. And we're going to look in memory a lot deeper into a later chapter, so hang on to this. And the mnemonic to help you remember it is that hippo that you're never going to forget that you see walking across Ohio State's campus. All right, two more analogies. So here's my friend Amy. Amy is an almond, and I want to tell you a special power that Amy has. So you know when your friend tells you some information, like maybe they just got back together with their ex-partner, and you're like, I'm not sure what emotion to feel about this. Should I be happy for them? Should I be worried about this? Well, Amy is super good at figuring out how to respond emotionally to things. For instance, if you see a snake, Amy is really quick at being like, yeah, this is a fearful situation. You should feel fear right now. Amy is short for the amygdala. The amygdala is this tiny almond-shaped subcortical structure you can see here in green that's right behind the temporal lobe in front of each hippocampus tail. So you can see here, this magenta was our hippocampus, and this green is your amygdala. You've got one on each side of your brain. Now, the amygdala processes emotional information, or it processes sensory information and kind of like sifts out the emotional parts of it. So it gets input from the temporal lobe. So I want you to pause here and think back to our discussion of the cortical lobes. And can you remember what the temporal lobe does? So hopefully you paused and thought about it. But the temporal lobe is that structure that has a lot of higher level visual information. So it has cortical areas that process things like faces or scenes or objects. So what your amygdala does is it takes in this visual information from the temporal lobe, for instance, of a face or a snake. It assesses that information and decides how to react to it. So for instance, if you see visually a snake, your amygdala notices that it's a snake and decides that you should respond in a fearful way. Now, for my inside out watchers, the amygdala is basically that entire emotional control center represented by these little people down here in the corner. Okay, one last analogy, I promise. So here's Nicholas. Nicholas has been playing the scratch-off lottery for forever, and he finally won. He got a huge monetary reward, and he is stoked. What is the first thing Nicholas does with his money? Well, he goes to the Mercedes-Benz dealership, and he gets himself his dream car. So now, every time Nicholas drives around in his Benz thinking about the lottery, he feels so pleased and content. So this, kind of a stretch, but helps you remember the nucleus accumbens. So the nucleus accumbens is a region in the frontal lobe. I've shown it here as a teal circle. It's in a region called the basal forebrain, which is not something you need to memorize, but just to kind of break it down for you. Basal means base, so kind of at the bottom of the brain, which you can see here, it's at the bottom of the frontal lobe. So basal forebrain just means bottom of the front, and that's where the nucleus accumbens is. So the nucleus accumbens is active after reward, for instance, like winning our lottery, and consequently after addiction, because you're really seeking more and more of that pleasurable thing. But reward doesn't just have to be monetary, like when Nicholas wins the lottery. It can also be social. So studies have shown that when a person has a strong social connection with their friends, so they have high social inclusion in their friend group, their nucleus accumbens becomes really active.